Winter vomiting disease. Vomiting, we just see it. Winter. You can see here the number of outbreaks during years. And what happened very regularly, all winter, we get again new outbreaks. So you see we have peak of 500 outbreaks, then 300 outbreaks, then 400 and so on in winter. This is usually United States. Sometimes this is the same number of outbreaks during the year. In blue you have in United States. This was focusing on only oysters. You see the peak, January, February, March. And in French, in 2009, the peak was a little bit later. So there is no general. Let's say the peak is usually in winter, in United States and France, but can also be a little bit later, spring, autumn, winter, autumn. And this is very regular. Okay, the problem with noroviruses, the main problem is they are not cultivable, so there are no cell line available. And when we work with norovirus, we have to get stools for to begin all the work. This is the main problem. There is no long-term immunity. It means that you can make infection each year. High variability, Jose just was speaking about it. High genetic variability, you can see here a tree on the gene of the capsid. This is genotype 1, and this is genogroup 2. If we are looking the percentage of cases, we can easily see that there is one genogroup which is very dominant. It is genogroup 2.4. This strain is very important, but you have all the time a lot of different strains. Then we have periodic emergence of new norovirus because of variability of genome, and Jose asked a little bit about it. We had in 2004 at least 2 pandemic strains, 1999, 2002, and then in Australia in 2004 we get a new one called Hunter virus. They begin to detect them. Only 5% differences in amino acid sequence of the capsid, and we get a pandemic with outbreaks in Netherlands, Japan, Taiwan, and so on. This is a nice slide to show you that the groups, the pandemics, the strain changes. Here we had the 2004 Hunter strain apparition in blue. Then the year after we had again this main strain, but then it was changing and we get another strain going to another pandemic and so on. So we have all the time circulation of different strain of norovirus as a function of the year. So don't forget other waterborne viruses. We had a good historical example. Poliovirus was a very high, had a very high transmission through environment. So now is under eradication, but we have other enteric viruses, which should not forget. First of all the enteric viruses provoking gastroenteritis. Rotavirus, I will not say some more about this because we had a lot of details. But perhaps we can focus on one thing. Rotavirus and adenovirus 40 and 41 are the biggest in size. So when we are discussing about enteric viruses, we are 70 nanometers. We had also sapovirus, another genus very close to norovirus, and astroviruses, which also provoke gastroenteritis. Then hepatitis virus. Hepatitis viruses, hepatitis E and A viruses, and enteroviruses, non-polio virus, Coxsackie virus, A, B, ecovirus, are also transmitted through environment. Let's say they have all 20, 30 nanometers single-strand RNA inside. Excretion, very high excretion. This is important for all enteric viruses. For you have excretion of between, let's say, 10 to 3 to 10 to 10 viral particle per gram of stools. So this means that the initial patient is the origin of a huge amount of viral particles. And during days, 3 to 20, 30 days excretion. So this is a very high amount of viruses which are excreted by humans inside the wastewater. Now, some example about the way of transmission. Of course, it is the fecal-oral route. So you need a fecal pollution, and it goes in the body by ingestion. So the most frequent one is person-to-person. No doubtly, person-to-person transmission is very important, and it was estimated, but it's usually very difficult to estimate person-to-person transmission. Nevertheless, we have some data, 80 to 90% is person-to-person. We have a very high capacity of transmission. What is meaning the R0 number of secondary cases from one case is very high for noroviruses. 14 without a hygiene procedures, 2 with high hygiene procedures. Why? Because of the high excretion, of course. We have a high number of particles in the stool. Some microgram of the hand is enough to contaminate the next person. Low infective dose, 10 to 20 viral particles. So 1 gram of stool may infect 5 million people. One more vomiting may also infect 3 million people. No immunity, no long-term immunity, and of course very high resistant in environment. They are the reason why we have so high transmission. Then, after it, places. The cruise ship virus, of course, provoke a lot of outbreaks in cruise ships. Why? Because of the confined setting of the person. And just for March 2013, there were 3 outbreaks described just for 1 month. So you see that it's very frequent. And you see we had at this time in different cruise ship 121 persons infected among 2,070 on the boat, 276, 4,084. Therefore, we need specific procedures for boats to cleaning the boat, because when you have vomiting disease, you may have spread on viruses on the boat. Of course, it is the same in hospital, nursing home, elderly home. Some data describe a very high percentage of outbreaks in elderly homes. 71% of all the infectious disease of elderly home. Food handler, we already saw it. Food handler, hygiene is very important. We have a lot of description of such kind of outbreaks. Of course, I choose this one. Perhaps this one was in January 2001. 231 persons were infected just because of that investigation revealed that the baker was suffering of gastroenteritis and he had vomited in the bakery sink the day he prepared the rolls. So this all the time we should keep in mind that hygienic procedure is very important for the transmission of such kind of virus. Okay. Oops. Water. We come to water now. The water, there is a problem to make the proof that your outbreak is provoking by drinking water. What is the problem? The problem is that you have to detect the virus in the stool. There is no problem for this, because you have high quantity, I just say it. But then you have to make the proof that the water is the origin. And then you have to find the virus in the water. So when it is a distribution water system, it's quite not possible, because you are at least 24 hours after, you have to come back and you have no samples. Usually, with food, we get some samples all the time, keep until 72 hours after, then you can come back to the food. But water is usually very difficult to get the water. There are some examples, but the examples are usually linked to wells. Because with wells, you can go to the well and make some analysis after. So we have some proof of transmission of norovirus by drinking water. This was the case of some scouting camp, and what was made, usually what can be made is making a relation between the water consumption. You see here 0, 1, 2, 3, 4, or 5, or over 5 glasses of water, and make a link with the symptoms. 50% infection, 75, 93, 96. So the more you consume the water, the more you get the disease, and you have a clear relation between both. And this can be made. It's a classical dose-response effect. And this can be a proof that the water is at the origin of the outbreaks. Because even in this case, it was well. And this well, no norovirus was found. We found in stool, we found a dose-response relationship, but we never found the virus in the well. What was made was a clear description of a fecal pollution with classical indicator. We can discuss it about tomorrow, or what is a fecal contamination indicator. We have other examples in which we found fecal pollution. We found norovirus in the stool, but we found no virus in the water. This is usually the case. Okay, now come back to food, environment, shellfish. We describe it. The main problem, of course, is shellfish. Why? We describe person excrete a high quantity of viruses in the water. Water is polluted. Shellfish filtration, a high amount of water to feed themselves, of course, and virus absorbed on the oyster, and we consume then raw. So everything is okay to get outbreak with shellfish. So this is the main problem. But I'll show you some interesting results now. So of course, this is a clear description of transmission to humans through water, shellfish, and again, human. The other problem with the environment is, of course, irrigation. When you get virus in your water, you make irrigate, and then you may have also some problems with all the vegetables, fruits consumed crude, like raspberries. We have a lot of outbreaks with raspberries in Europe, salad, sandwich, and so on. So we have, let's say, speaking about all this in one case. Okay, this is the results in Europe. Food vehicle of norovirus. What are the main vehicles? Of course, shellfish. Okay, shellfish, crustacean, mollusks, 20%. This is very usual in Europe. Since 2007, I said you that we begin the description. Shellfish were all the time present, and norovirus is the first one.